Hello everyone. Today I am presenting our project GANvision, a deep learning journey for instant image enhancement. Before diving into the details, just take a look at these merge images. On the left side, you see the output of our system. On the right side, you see the hazy image, the low quality input. The difference is track. Our goal was to create a system that can make this kind of a real-time transformation possible. And that's what GANvision achieves. Introduction. Why is this project necessary? So basically, high quality clear images are essential in many critical fields, including the photography, autonomous driving, or remote sensing, or any other surveillance part. However, environmental factors like haze, fog, and low light contents will constantly reduce image clarity. So the existing solution have significant limitation, such as the traditional method uses the handcraft models, which are slow and inflexible. Many deep learning solutions are also computationally heavy, making them unsuitable for the real or dynamic application. But the GAN vision is our answer. It's a lightweight, real-time image enhancement framework using a generative adversarial network. It learns to restore the sharpness already from the hazy and the clear image paths, making it efficient to perfectly for the real-time dynamic implementations. We defined three core objectives for this project. First, we had to identify and pre-process a suitable benchmark dataset of hazy and clear images to train the model. And secondly, our main design objective was to implement a real-time image enhancement model using the GAN architecture. Finally, we need to evaluate our model performance using industrial standard image quality matrices such as PSNR and SSIM. The problem statement over here is the modern system demand clear images, but factors like haze and poor illuminations degrade the visibility and impact the real-time applications. Traditional methods can't keep up. So our solution is a GAN-based approach that learns directly from the hazy and the clear image pair, and minimal latency is there, and we avoid the need of for complex things. So we are avoiding here the time consuming. We are trying to build the result in fast manner, scalable and visual pleasing solutions. The methodology. Let's look at the methodology and the architecture of our system. Our process is to divide. Our process is divided into three main phases. The phases are data collection. So basically, we start with a paired data set of hazy and corresponding clear images for supervised training to the model. Secondly, the phase is training phase. This is the core of the system. We use a generator, which is a unit architecture, to take the hazy image and convert into the clear one. And the discriminator patch GAN that evaluates the authenticity of that generated image at the patch level, ensuring it looks like a real. Yeah, basically, training involves two keys over here. First one is adversarial loss for the realisticness, and L1 loss for the pixel level accuracy. And the third phase is inference phase. After the training of the model, the discriminator is discarded. It is removed, and we use only the generator. The lightweight structure allows to produce clean and dehazed image from any unseen hazy inputs. And the evaluation performance. Our success was measured using two standard image quality matrices, such as PSNR and SSIM. So PSNR, or peak signal to noise ratio, measures the pixel level difference. A higher PSNR indicates less distortion, and a value above 20 decibel is generally considered as a good for the 8-bit images. And SSIM, which is structural similarity index measure. It's a perceptually driven. It looks luminance, contrast, and the structure to align more closely with how humans see. Basically, scores range from 0 to 1. So basically, if the score is above 0.85 or higher, are considered as a good benchmark performance. As you can see in this image sample that has been given, what were the hazy images and what were the real images and what the model generated. These are the from the inputs to the generated images, and the PSNR value and SSIM values are right here on the screen. Overall, for out of 5 of our test exceeded or met the benchmark for the good dehazing performance, as you can see here. And finally, the conclusion. In our conclusion, conditional GAN based image dehazing system perform exceptionally well. The quantitative evaluation, the strong PSNR and the SSIM values confirms that we achieve both excellent pixel level and eventually the perceptual similarity to the original clear images. These results validate that our model efficiently restores the clarity and the sharpness, demonstrating a good performance. So now we're gonna see here. Yeah, here is the Jupyter notebook code where we have written the codes and we have trained the GAN model and we have created the discriminator and the yeah, we have created the generator and the discriminator. And finally, we came to the code where we have our PSNR value and the SSIM value, which is good because the it should be above 20 decibel, and the SSIM which are more than 0.85 are good, are being considered as good. So here, as you can see, as you give the input of hazy images, it processes and the ground truth image is given to the model and the image what was generated by the model, and later both of this generated and the ground truth image are compared. Then we get the PSNR value and the SSIM value. Okay, now we have the front end also. So for this application, in order to start this application, you're gonna type python app.py and you're gonna press enter. Once the server starts, you're gonna click on this URL, so you will be shown this one, landing page, or this is the home page. You can log in as well. This is where you will be redirected after you log in from your login page. Now coming to the detect tab or upload and DH button over here, you will be redirected to the detect tab where it says GANvision image dehazing. In order to analyze, you have to provide an image. So I have few images over here. As you can see, it is fully hazy images over here. So I'm going to give this image as an input. On click of dehaze, as you can see, uploaded hazy images, and as you can see here, dehaze images. So we can see a big difference among this two images. Let us try with another one, which is this one. As you can see how the hazy uploaded image was there and how it dehazed it. This is how our project gonna work. So you can contact us, or if you have any question related to that or you want to know something, then please please contact us. Thank you. I'm happy to take any questions. Thank you.